Giuseppe, please get going.
Okay, well, thank you. Thank you so much. And thank everybody for being here, apparently. So, my name is Giuseppe D'Angelo. I work for KDAB. And today, in this very short talk, I want to tell you a little bit about GammaRay, this visual debugger for Qt applications. Before I get started, can I just see a quick show of hand? How many of you already know about GammaRay or use it? Well, I'd say around 40%, 50%. I still see entire chunks of people that don't know about this. So I think that has to change. Does this talk, all right? So I won't spend time talking about me. You can meet me at the KDAB booth. We're just outside, right? But I want to talk about the tool, okay? What is GammaRay and what do we use it for? So GammaRay, in one sentence, is a high-level visual debugger and profiler for Qt applications. So like a debugger, you can use it when you have troubles, you think your application is not doing what it's supposed to be doing, you launch it and you inspect what's going on. But this one is peculiar in the sense that it's a visual, it's not a command line tool, you do see what's going on, and also it's specific for Qt applications in the sense that it's got a lot of logic, a lot of UIs for it that enable you to see what's going on inside your Qt application and therefore more easily debug it. It's developed by us and by also a bunch of awesome people that contribute code to it because it's free software. It's something that you can download right here, right now from, well, not right now, but any time after this talk from GitHub, okay? Or just Google GammaRay Qt. I'm feeling lucky if that thing is still there and just download it, okay? So what can I do with GammaRay? So I launch it, what do I do with it? Well, I can inspect interesting things about my Qt application. For instance, I can inspect all the QObjects inside your application, and for every one of them, I can figure out what are their properties, the current values, any signal that is emitted by that object or is locked, and what are the connections that are active on that object, and when a signal is emitted. I can investigate all the widgets in my application. So if you're building a Qt widgets application, you want to analyze their layouting, their painting, figure out if there is something wrong with the tab order, things like that. If you have a QtQuick application, not a widget application, well, you can also visualize the QtQuick scenes inside your application. So you can debug things like the size of your elements, their positioning, figuring out layout issues, but also figure out some interesting things like QML issues, things like maybe you got recursive bindings. If you ever encountered one, you know what I'm talking about. How do I debug which bindings are, for instance, forming a loop? And that's a bad. Yep. I can also inspect something relatively lower level inside QtQuick. So for instance, I can analyze the scene graphs and the render of QtQuick in order to search for maybe some extra bits of performance. And much more, right? So I could spend few minutes talking about this, but I think this is a tools talk. I think it's better if we just run it and see what's going in there. Just a second, why talk about a tool, right? Well, just as I proved right here, right now, at every single Qt event I've been at, and I've been with the Qt community for something like 20 years now, a huge number of people still don't know about this. And I think it's not great. I think that as developers, we should always aim to have the richest toolbox that we can ask for, right? Buy all the tools that money can buy, but this is free, so you never have to buy it. Just in case, right? It's debugging help, and likely you will never get in trouble, but you know, lifetime sometimes gives us lemons, so why not making lemonade, okay? So, as I said, I'm just going to run it and show you a couple of demos until I run out of time, because why not? That's, I think, the best way to understand and visualize such a tool. So here I am. I'm going back into Creator, and let's say I start one of the demos that actually come with Qt. That's one that you can find inside your Qt installation. So that's just stock Qt application. I didn't modify it in any single way. And now from my command line, I'm just going to launch GammaRay. I'm just going to ask it to run into that thing, and voila. So what is this? This is GammaRay in action, active on that demo that I just launched. As you can see, it's a developer tool. It's a tool made by developers for developers, so there's a little bit of information overload, but I take just one second and navigate through this UI so that you can better understand what's going on. On the left side here, you can find many tabs, many different entries. These are individual individual sections that you may want to analyze. So inside this application, I may be interested into debugging, I don't know, all the events that are going on, all the QObjects inside that application, all the QtQuick scenes, the entire contents of the resource system. So everything which is in there, which maybe includes things like icons, various artwork that you have stored inside your application, all the signals that are getting emitted. Well, this moment the application is idle, you don't see anything here. All the timers, and so on and so forth. All right. So just for the sake of exercise, I will actually focus on probably the one that I use the most, which is the QtQuick Scenes Inspector. And what you see here on the right is a visualization of what's going on inside this application, which is, of course, a QtQuick application. So on the top left here, you see the complete item tree of your application. You can select any element in there and figure out on the right-hand side all of its properties, all of its meta methods, all the connections are to it, what are the bindings, where this element is being created from QML, and so on and so forth. A lot of interesting information. Down here, you can also see a live preview of the application. So this is live. If I go back to the running app, as I said, this is a live demo. It's pretty interesting. Okay, and I click on this button. You see the application is doing something, but also my preview, but over there, it's also changing. Okay, so I can inspect things, and I got a bunch of interesting ways to inspect parts of my application. So for instance, I can select this little tool, which is called the pick element tool, and I click just on one element on my scene here. Sorry, let me zoom in so you can see. Okay, I clicked on that icon over there. And this is selecting the corresponding element in QtQuick, it's telling me this is a shader effect. Okay, and these are all of its properties and everything else I set up in the QML file. Okay, hopefully this makes a lot of sense. We can do also something extra here, which is actually we can try and modify some of these properties. Since this is built on top of Qt technology and signal slots and properties, you can actually go in there and 3D modify some of these properties. Let's see if this works. Yep. So I just put it a rotation and set it to 45 degrees, and you can see that the icon has rotated, not just in the preview, in the actual app, right? And you can play with this thing in order to figure out something wrong with your application. So what kind of things can go wrong in these kind of applications? Well, many subtle things. You may have alignment issues. Why is this element not where it's supposed to be on the screen? Sometimes, quite often when you're starting with QML, you have the problem that you have elements that should be visible on the screen and you don't see them. So where are they? Did you accidentally place them behind another element? Maybe you have that. Did you accidentally set their size to 0? So the element is there, it's visible, but you set 0 by 0 size. Or maybe you just accidentally formed, wrong anchoring and place the element outside of the visible screen. So again, it's there, it's not 0 by 0, but it's not visible. How do you debug this? Well, it's incredibly effective to be able to go into your item tree, find the element, and see what's wrong with it, rather than start guessing what are the properties that are wrong. Is it the size? Is it the positioning? Is it the opacity set to 0? Things like that, right? So that's really the tool in a nutshell, right? That's the high-level overview of this. Now, as I said, let me show you another couple of things. So first and foremost, how do I use GammaRay? You don't need to modify your Qt application. This is a not invasive tool. So you just run your application as you compile it. The simplest way possible is to just launch the application inside GammaRay. You can either do it from the command line, or you can use the interesting UI that GammaRay pops up when you launch it. You just put the path of your binary, and that will launch your application. You can also attach GammaRay to a running application. That works, although as just like a debugger, when you attach it, you may miss a little bit of information about your application. That is the information, everything that happened before GammaRay got attached. So I usually suggest people to run it within GammaRay from the start. And just a little bit of a more advanced usage. So GammaRay itself is actually like a regular debugger made up of two distinct components. There is a component that we call the probe, and that's the component that actually injects itself into the running application. And then there is the client of GammaRay, which is the UI that I've just shown to you. So these are two distinct components for a very specific reason, to allow for remote debugging. So as long as I run everything on my machine but I don't even see the difference or appreciate the difference. However, these two components are distinct and they talk to each other via TCP/IP, which means that you can run this in a remote debugging scenario, just like JDB server. Okay, the scenarios are very interesting when we talk about embedded or mobile applications. So you can have just the probe that you're going to cross-compile and deploy on your target hardware. You run your application on your target hardware within the probe, so within GammaRay, and then you just tell your client to connect to your running application via TCP. Yep. So, a couple of other use cases. In QtQuick, we've seen what GammaRay can do. GammaRay can visualize your scenes tree structure. It shows you a live preview of the QtQuick scene, including information about sizing, anchoring. We can interact with your application from within GammaRay. And we can also inspect a lot of information about the scene graphs. Yep. And then, as I said, let's actually show this example. So why is element not visible? And let's see how I can solve this problem in 1 second with GammaRay and not in more than that using something else. And so why should I spend more than 1 second figuring out why something is going wrong, right? Oh, okay, thank you. Thank you for Ubuntu for crashing on me. That's great. So I got another little example for this. Let me just very quickly close this thing that I launched before. Apologies for that. It's a live demo. That's the challenge of live coding. So can I run this? Yeah, okay. I got a contact list here. Okay, that's a very simple QtQuick application. Okay. So it's showing some names. And I swear that when I wrote this code, somewhere in the code that I wrote over here, and just to show you that I can write QML, I'm not just somebody that talks about QML, within each element, there's supposed to be a little icon that is represented through this image that I load. Okay, this image comes from a given model. It's loaded. It's got a size of 64 by 64. And it should be there and it should be visible, but I don't see it. Sorry, I don't know what's going wrong today, but yeah. So I write some code. I think the code is correct. I launch the application and I don't see the icons corresponding to each of my entries here. So why do I don't see them? The image is here, so I start investigating. Is it visible? Should I set like visible to true? What do you think people think? Are things visible by default in QML or they're not? You see, we're starting wasting time guessing how QML works. No, things are visible by default. It's not that. Is it the size, width and height? Well, I could double check them, but this sounds reasonable. This should not be 0 by 0. So again, what's going wrong? Let's just eliminate the guessing from the equation and let's use a tool for this. So once more, I'm going to launch GammaRay again. This is finding the process. So this is actually attaching to it because I'm doing it things slightly different here. Okay, so now I see my live application here. I can go investigate. So let's have a look at this row. Okay, that's just one row, which is an item in QML. So there is some text in it, that's fine. There is a mouse area over it, that's also fine. And there's an image. And where is the image? Well, I don't know if you can appreciate here on the beamer or on the monitors. The image is just outside of the visible canvas. Something went wrong there. There's even an icon, because in GammaRay we coded this condition especially, right, telling me, watch out, because you got an item which is self-visible, it's just out of view. So somebody made a positioning wrong somewhere in my code. And actually, I can also visualize that positioning going wrong. Again, it's a bit difficult to see perhaps on the displays, but here, perhaps you can see this horizontal dashed line here, and there is another one vertical, and this is representing the anchoring of that particular image to the rest of the QML file, and this is telling me there is a wrong anchoring. You just anchored the left side of the image to the right side of your row, and that's not what you meant to do. You meant to do a right-to-right anchoring. So the fix is simple. And now that I have identified the bug, okay, silly me, it was just a little mistake in my code. I can close this, close that, and fix this by saying this is not a left-to-right anchoring, this is a right-to-right anchoring. Yep. So I can eventually rebuild this thing, run it again, and now I see the icons. Okay, so as I said, I turned that guessing game into a way more precise way to figure out why is my element not visible. And I did that in 2 seconds. Okay, no need to guess, no need to figure out what's wrong from the QML side. Okay. One more. Why not edit? As I said, I keep going until I run out of time. So, state machines. Let's run an application which is based on a state machine. So this is another little demo that it's somewhere, I guess, in the Qt demo. Okay, so there is this little application which is driven by a state machine. Okay, now I am in this home page state where I see hello world, and then I can click on this calendar thing, and I see some sort of calendar, and then I can click on a day, and this shows me that I selected day number 8, and then I can go back, and go back again. Okay, that makes sense. I can also click on these rockets, and there's a rocket scene shown over there. Sorry. I click on rockets, and there's a rocket shown, and oh, wait a minute. There's something wrong with my state machine. Okay, so what do? Do I go into my C++ code and try to figure out how my state machine is misbehaving? No, I launch GammaRay. And I attach it to this thing, okay, which is this example. Crossing fingers, yes. There's going to be a state machine visualizer in there. Okay, now it's a simple application. There is one state machine, but I can select which state machine to debug. And this is showing me that state machine and which state it's right now. So I'm in the home state. Okay, let's go back to the application. I click calendar. So now I'm navigating into the calendar state. I click to the day state. Okay. I can go back, as I've shown before. So if I click on rockets, it stays there, and then it quits the state. So, okay. Does it mean that there is a transaction between the two states? Yes, there is. If you take a look on the right-hand side, again, apologies for this, perhaps you can't see it on the big screen, but there's this little thing, this little nugget there that says there is a timer, there's a timeout, there's something put in there that automatically transitions from the rocket state back into your home state after a given timeout. Yeah, so maybe this was wrong, right? I didn't mean for this transition to exist at all, or it was not supposed to be triggered automatically or something like that. So, yeah, I can fix it now. Now I know what to look for. Yep, hopefully that makes sense. And, yeah, one last thing, since talking about QtQuick, there is also some more advanced use cases where I may be interested into debugging the performance of my QtQuick scene. Especially on constrained hardware, like embedded or mobile hardware, sometimes it's too easy to create a QtQuick scene, which looks good. However, it's too demanding in terms of resources, especially GPU resources. So I can ask GammaRay to configure my QtQuick application in a way that it shows to me what's going on from the graphical point of view. And there's a few questions that I can start asking. For instance, how often is my scene redrawn? Like, do I have something which is constantly redrawing my screen 60 times per second? I can do that, but that's, of course, something that's putting some strain on my system resources, or is it just draining my battery? How many times is a given pixel drawn? If I have too many things stacked on top of each other, that single pixel may be drawn a number of times, and that's not good for, again, performance. How many draw calls are necessary to draw a scene? Ideally, the fewer the better, but how many exactly? Okay, this is called matching, and more. And all these profiling options are available, again, just one click away. So I'm going to run another application again. Let's go back to the coffee machines thing. Let me attach GammaRay to it. Coffee machine, come on. Second, and here we go again. And down here in the QtQuick inspector, you have these visualize buttons that enable these more advanced visualization techniques. Okay, so for instance, here I may want to visualize, I don't know, changes, like how often things change in my application. Okay, now it does look like nothing's happening, which is good. If I'm not interacting with it, nothing's happening. But you can see some flashes here and there, and that is a signal of something which is changing on the screen. Yep. And effectively, only things that are changing should be changing. Okay. Yeah, let's ignore that. Today is not the day. Okay, there is, even more than this. So I can also show you some GammaRay for Qt widgets, some GammaRay for Qt3D, but indeed, I don't have time right here and now. This is supposed to be a very short introduction. If you want to know more about all of this, let me yeah, sorry, I don't have time for this today. If you want to know more about this, please reach out to us. We are at the booth just outside here. Or grab a GammaRay sticker, so put it in your pocket, and when you go back home, you know about it, okay? So thank you very much, and I have some time for questions. Yeah.